So in last lecture we have seen that how Laplace transform can be useful in using our system or our circuits for the variety of the input signals or variety of the components inside of it. We have also seen that inside the Laplace transformed circuit, the value of the resistance doesn't change and it always remain R or the real value. Similarly, in order to see the effect of Laplace transform on the inductor, okay, so that is the inductor and the applied voltage here is, let me see, that is plus minus and that is V L of t, and the current which is flowing through it is I L of t, while the value of inductor is L. So what will be the value of L in the S domain? Okay, so we can very easily see that recently we have seen that V L is equal to the L d I L of t divided by dt. Okay, so that is its value. So similarly we have also seen that in converting this f of t divided by dt into the S domain, this is t, this is S domain, this derivative term will be replaced with this S, while this f will be replaced with this f of s. So this will be the convergence of any derivative term into this one. Similarly, now taking the Laplace transform of this function, what I will get? I will get here V L of s equal to the L, this derivative term will be S and this current will be I L of s. Okay. Similarly, now rearranging this equation, what I will get? I will get V L of s divided by I L of s, and that will be S of L. Okay. So we have previously seen that according to the Ohm's law, what is this? This is the impedance, or we can see it as well, X of S, and that is S of L. So that is the impedance of the what? That is basically the value of inductor in the S domain, and it can be, okay, it will be like this one. So inductor in the S domain will be represented with these things. Similarly, in order to see the effect of it on the capacitor, what we have to do? So suppose we have a capacitor here, okay, so that is plus minus Vc of t and the current through it is Ic of t. Okay. As we already know that the value of Ic of t is equal to the C dVct divided by dt. Okay. So now again taking the Laplace transform of both sides, what I will get? Ic of s equal to the C, this derivative term will be replaced with this s, and it would be Vc of s. Okay. Now rearranging it, what I will get? I will get Vc of s divided by the Ic of s equal to the 1 over S of C, or this one is, we can also see that according to Ohm's law, this is also the impedance. So X C of s is how much? That is 1 over S of C. Okay. So that is the value of capacitor in what? In the S domain, and here it will be represented by 1 over S of C. Okay. So that is a very interesting phenomena in which we have a capacitor, or any capacitor of capacitance C will be represented by 1 over S of C. Similarly, the inductor will be represented by S of L. So in the same manner, any circuit can be converted into the S domain, okay, and analyzed by using the same formulation. So suppose if we have a circuit here, okay, that is basically very simplified circuit, and here we are applying this V of t, and this V of t is 10 volts, okay, and the value it has is 2 ohm. So what I want to find out? I want to find out the current I of t. So how can we do it? So in order to do it, this is basically, this V of t is basically the input which I am applying here. So and here this I of t is the output. So in order to do it, let me represent this one as a system. where this input will be applied, okay, and I will get its output, which will be the I of t. So, in order to do it, I have to convert my circuit into S domain. So, in converting my circuit to the S domain, this will be the resistor, and here we will have the input. Here the input is 10 volts, which is 10 u of t. Okay. This u of t is how much? That is 1 over S in my S domain, and this is 10. So, that would be 10 divided by S. So, here it will be 10 divided by S, while the current here will be I of S, okay, and the resistance will remain same, because I have previously seen that this is the linear element and it does not change here. Okay. So, how much I of S will be here, because now this is in S domain. So, here this will be replaced with I of S, and here it will be V of S, and the value of V of S is how much? That is 10 by S. Okay. So, now in order to convert it, what we have to do here, we can see that this is 2. So, V of S, this is V of S and this is I of S. Here I can see that V of S is equal to the I of S multiplied by 2, and inside of it we have to write the transfer function, and you have to look at the transfer function as transfer function is equal to the output divided by the input. Okay. So, in this circuit the output we have is I of S, while the input we have is this V of S. Okay. So, from this formula we can very easily see that the value of I of S divided by V of S is how much? That is 1 by 2. Okay. So, now writing it here, what I will get? I will get when this input will be applied at the output, okay, when input is 10 by S. So, output I will have, it will be multiplied with this term, and here we will get 10 by S multiplied by 1 by 2, and here we will get 5 by S. Okay. So, that is what? That is the I of S. Now, in order to find the value of I of t, what we have to do? We have to transform it back into the time domain. Okay. So, I of t here, and here this is what? This is 5 by S. So, here in time domain this S is u of t. So, in time domain it will be 5 u of t, okay, which is the 5 amperes. Okay. So, the answer of this question is known by using the what? By using the Laplace transforms. Okay. So, that is it for today, in which we have seen the application of Laplace transform in finding the solution of a simple resistive circuit. In our upcoming videos, we will see the application of it in variety of other circuits as well. Till then, take care of yourself, and I will see you soon.